All right, we'll start here by reminding ourselves what we're asked to calculate, which is the molarity of K plus ions. So that is the moles of K plus ions per liter of solution. And we want to find a way to calculate each of these. So the K plus ions come from the potassium phosphate. Since we're comparing potassium phosphate to potassium ions, we need a balanced chemical equation, which is our dissociation reaction. So using our dissociation reaction and the appropriate mole ratio, we can determine how many moles of potassium ions we have. As always, we're going to determine our mole-to-mole ratio by looking at the units we want to cancel, which is moles of potassium phosphate. Our mole-to-mole ratio indicates that every mole of potassium phosphate is going to release 3 moles of potassium ions. Okay, and finally we can multiply by liters so that we end up with the only surviving unit as moles of potassium ions. All right, so now we know how many moles of potassium ion we have. We can plug that into our equation up here. So this is 0.210 moles potassium ions. Our liters of solution comes from our new solution volume, which is the 120 plus 280, or 400 milliliters, and that's 0.400 liters. And we do the math. This comes out to be 0.525 moles per liter, and we can justify all 3 sig figs, so we're done.